Alright, so today guys we're doing the 4-3 notes video over congruent triangles. Okay, so up at the top it says into congruent triangles. Remember, congruent means the exact same or equal. All of the parts of one triangle are congruent to the corresponding parts or matching parts. Okay, remember from chapter 3 when we had corresponding angles, we were talking about how they were in the same seat of the car, right? Corresponding, they were in that same seat, they were matching. Okay, so all of the corresponding parts of congruent triangles are going to be congruent. Okay, this includes both the corresponding sides and corresponding angles. Okay, when I'm talking about one triangle, there are 6 different parts. I have angle H, I have angle A, I have angle M, right? I have 3 angles. Okay, I notated those with 1, 2, and 3 loops just to differentiate that they could be different measures. Okay, so I have my 3 angles, and I also have my 3 sides, right? So I have side HA, I have side AM, and I have side HM. Okay, so there are 6 total parts just in one triangle. All right, so what we have right here is called a congruency statement. If triangle HAM right here is congruent, there's my congruency symbol, to triangle PIG, then what we're going to do right here is we're going to match up all of the corresponding parts, right? The matching parts, okay? So I've gone ahead and marked this triangle, right, with my little tick marks and my loops, but I don't have anything marked over here. What we need to follow always is the congruency statement, okay? However they named the first triangle, in this case they named it HAM, we have to follow that same order for the second triangle. So we have a full congruency statement here. HAM, PIG, right? So if I'm talking about my angles, angle H, right, is the first letter of this first triangle. It has to match with the first letter of the second triangle, which is P. So angle H is going to be congruent to angle P. Okay, so I marked those with 1 loop each, right? Because I know that those are matching, so those are congruent when my triangles are congruent. Okay, A is the second letter, so it has to match with the second letter over here. So angle A is congruent to angle I. All right, and then M, my third letter, has to match with the third letter over here. So angle M is congruent to angle G. Okay, so it's really easy when they're positioned in the same spot. Like, yes, we can always follow our statement, we should follow our statement, but I can also tell by the way the triangles are positioned that H and P go together, A and I go together, M and G go together. That's fine and dandy, right? But when we have a rotated figure like this, right, when my triangles are not sitting in the same spot, then I have to follow my congruency statement. Okay, so let's finish out this HAM and PIG with my sides. Okay, so if I look at side HA, right, I've marked it with 1 tick mark over here, and H and A are the first 2 letters of my statement. So I would just follow the first 2 letters of this statement, PI. Okay, side HA is congruent to side PI, so they both have 1 tick mark. Side AM, right here, well, A and M are the second and the third letter, so the second and the third letter is I and G. So I know that side AM is congruent to IG, and then lastly, HM, right side HM, well, H and M are my first and third, so over here the first and third is P and G. So these are congruent sides. Okay, so 6 total parts when I have congruent triangles, right? I have to match up all 6. Okay, so this second example is good because now my triangles are not positioned, right, in the same spot. Okay, this one has clearly been turned and rotated. So I want to make sure that I follow my congruency statement. This tells me every single corresponding part. Okay, now here's A. This is a side. Remember, it takes 2 letters to create a side. So side BC, I'm going to follow the order in my statement. Second letter, third letter, second letter, third letter. So EF. So I know that BC and EF are congruent. I'm going to mark them with matching tick marks, right? 1 and 1. Angle F. Angle F is the last letter over here, so it has to match with the last letter over here. Angle C. So F and C are congruent, so they have matching loops. Angle A is the first letter up here, so I'm going to match it with the first letter over here. Angle D. So I'm going to mark angle A and angle D congruent. And I gave them 2 loops because, again, I don't know what the actual measures of these angles are. Okay, I don't know if A and C are the same, so they can't have the same number of loops, right? I only for sure know that A and D are congruent, so those have the same number of loops. Same with C and F. Okay, so now D is asking for the measure of angle E. So now we actually want to figure out, well, what is this angle equal to? Okay, remember, angle B, the one that we have not marked, has to match with angle E over here. All right, so angle B is 77 degrees. It's the middle letter. The middle letter over here is E, so we know that these are congruent. So this is also 77. Okay. Side DF. Okay, so what I want you guys to pay attention to is that letter A and letter E. Letter A, side BC, had this line above it, right? Meaning segment BC, right? So this should also have a line above it. Okay, so segment BC is congruent to segment EF. Over here, we don't have that line, and we also don't have the squiggly, right? We have DF is equal to. So this is telling us that segments are congruent, right? What is a matching segment? Here, this means the measure of. When I do not have that line on top, and I have an equal sign, right? The equal sign, I want the actual measure if there's an equal sign. If I just have a congruency symbol, then basically what is your matching part, right? What angle or what side? Okay, so the measure of side DF, which is right here. Okay, DF is the first and the third letter. It has to match with AC. Okay, so I'm going to mark AC congruent to DF with 2 tick marks. AC is 5, so that means that DF is 5 centimeters. Okay. And then triangle ACB. Okay, so what we're doing right here is we are completing a congruency statement, right? Here was a congruency statement, and here's another congruency statement. It does not matter how you name your first triangle, right? I can do ABC, I can do ACB, I can do CAB, BCA. It does not matter, right? But however we order the first, we must follow the order of the second. Okay, the second part must be matching this part. Okay, so this one starts with A. Angle A was congruent to angle D, right? So I have to start this one with D. So triangle ACB is congruent to triangle D, all right? Then they do C. Well, C was matching with F. So now I have to put F. And then B was my 77-degree angle, so E would come next, okay? So however they name the first, you have to match the second in the same order based on those corresponding parts. All right, what this is called, right, when I'm matching all of my corresponding parts, right, there's an acronym for this. Corresponding parts of congruent triangles are congruent, okay? What that means, right, like I don't know what angle C is, but I do know that it's congruent to angle F because they're corresponding, right? Or like angle B is 77. Well, I know that angle E is also 77 because those are corresponding parts which are congruent. Okay, so this is called CPCTC. Corresponding parts of congruent triangles are congruent. So where this comes into play is if I have to solve, right, for one of my parts, okay, I need to make sure I'm following my congruency statement, right? The order of the second matches the order of the first. So it wants us to find the measure of angle K, right? It gives us all this information, angle M, J, and K, but we want to know what K is, right? So what I know from my congruency statement is that angle K, right, the second letter over here, has to be congruent to the second letter over here, which is angle M, meaning I don't need angle J, right? That's extra information. I needed to match up angle K with the corresponding part. So these are congruent, meaning these are the angles that I'm going to set equal to each other. K is 2x minus 12. That is equal to M, 5x minus 10. Okay, this is how I'm going to solve for x. I'm going to get x on one side. So that cancels right there. Negative 12 is equal to 3x minus 10. Add over 10. Okay, so negative 12 plus 10 is negative 2 is equal to 3x. Divide by 3. So x is equal to negative 2/3, which that's kind of ugly, but okay. All right, now we want to know the measure of angle K, right? Not x, I want to know the measure of angle K. So I have to plug x in into angle K. 2 times negative 2/3 minus 12. Okay, so figured out where the problem was, is we did not make this change right here. This should be 2x plus 11. Okay, so this is why we're getting some ugly numbers. So just change that to 2x plus 11, which means right here, okay, I have 3x, but I would have 11, so positive 11 plus 10, which is 21. Okay, so we're going to make that change right there. So 21 divided by 3, now our x value is equal to 7. Okay, so when I plug this into angle K, 2 times 7 plus 11, right, 2x plus 11, I get 14 plus 11, so the measure of angle K is equal to 25 degrees. So that was a little ugly because we forgot to make that typo. Okay, so up at the top of page 2 is the third angle theorem. And basically what it's saying is that if two angles of one triangle are congruent to the corresponding two angles of another triangle, so like for instance, A and D are congruent because they both have one loop, B and E are congruent because they both have two loops. Well, if there are two angles in each triangle that are corresponding and congruent, then that means that the third angles are also congruent. And this goes back to our angle sum theorem, right? The measure of the three angles inside of the triangle have to equal 180, no matter what. It doesn't matter what kind of triangles they are, all three angles inside have to add to 180. So for example, let's just say that angle A is 50. That means that angle D is 50, right? Because they're congruent. Okay, let's say that angle B is 100. That means angle E is 100, right? So if all three angles add up to 180, here's 150, that means that this angle has to be 30, right, because of our angle sum theorem. And the same thing over here, 150, right, that means this angle has to be 30 because it doesn't matter what type of triangle it is. All three angles add up to 180. So now we can conclude that our missing angle, right, C and F are congruent, right? 30 is equal to 30. So we're going to finish example 3 and 4 in our part 2 video. Okay, so this is part 2. We are doing examples 3 and 4, and that should be the remainder of these notes. All right, example 3 says find the measure of angle BDC. So remember, follow your letters, right? BDC, I want this angle right here, okay? So this is what I'm looking for. If the measure of angle A is 28 degrees. Okay, so this is not really the CPCTC, right, corresponding parts of congruent triangles. It could be, but what we're going to do here is some little angle sum theorem and also tie it in with parallel lines and transversals, okay? So we have 90 right here, okay, which if this is 90 right here, then angle B on this triangle is also 90 because vertical angles are congruent. All right, and then I have 28 degrees right here. Okay, my missing angle, if I take 180 minus 90, which is 90, minus 28, I get 62 degrees, right? That's my missing angle in this triangle. Now, we want to know what this angle is up here. Okay, I have parallel lines, right? I'm just going to kind of extend these out a little bit so that way y'all can see it. These arrows mean parallel, okay? So remember, from parallel lines and transversals, those parallel lines are my sandwich bread, okay? And here is a toothpick. All right, so this angle 28 is corresponding, or I'm sorry, not corresponding, alternate interior to this angle up here. And remember, alternate interior angles are congruent, right? They're both on the inside of the sandwich bread and they're on opposite sides of the toothpick. Okay, I'm not worried about all these angles on the outside of the triangle. We are trying to find the angles inside this triangle right here, right? Because those are the angles of my triangle. So 28 and 28 are alternate interior, and then that means up here 62 and 62 are alternate interior angles. Okay, so this is what I need you guys to write. Alternate interior angles are congruent. Right? The reason why I could do that is because I have these parallel lines right here to make that connection. Okay? Last one. If you don't have a picture, draw it. Triangle DEF. Okay? So I have triangle DEF. And I also have triangle PQR. Those are congruent. Okay? So the easiest way to do this, right? Because here's my congruency statement. I labeled it in this order DEF, starting right here, DEF. So I want to make sure that I follow that same order and in the same spots, right? Because I want to match up my pieces. So D and P are congruent, so I'm going to put P down here where D is. E and Q are congruent, so Q is going to go up top, and then R. So just make sure you're matching up how you're also labeling your triangles. That way you don't even have to think about it. Right? And here's our statement right here that we can also refer to. But what they're saying is that side DE is equal to 3x minus 10. So this side up here is 3x minus 10. QR, which is over here, is 4x minus 23. PQ is 2x plus 7. And EF is equal to y. So we want to find the value of x and y. Okay? So I have my triangles set up to where they match, so what I know is that PQ is congruent to DE and EF is congruent to QR, right? If I look at my expressions, I have more of them that have x than they do y, right? So I have to start solving for x first because I cannot take 4x minus 23 and set it equal to y because I cannot solve for two different variables at the same time. So I have to start over here. Right? These are the congruent sides that both have an x. These are the ones that I'm going to set equal to each other first in order to get the value of x. Okay? So when I move over to x, 7 is equal to 1x minus 10, add over 10, so 17 is equal to x. Okay? I am going to take this x and plug it in right here. Okay, because I want to know what this side is equal because it matches y, right? So I'm going to take 4 times 17 minus 23. Okay, so let me bring up the calculator. 4 times 17, which is 68, minus 23. So this side length, QR, is equal to 45. And QR is congruent to EF, so that means that y is equal to 45. And we have x right here.